What if an interstellar weapon struck our planet? That weapon has a name. 3 Atlas, a cosmic projectile moving at 61 kilometers per second, born before the sun and heavy with metal and momentum. Oumuamua was only the scout, a silent warning from the dark, but Atlas is the impact itself, carrying enough kinetic energy to erase continents and rewrite extinction into the present tense. We believe space protects us with distance, but at interstellar velocity, distance disappears. This is not theory. This is the simulation of what happens when a 7 billion-year traveler meets Earth at full speed. And like every cosmic execution, the story begins with the first intruder that crossed our sky. For 4.5 billion years, our solar system was a fortress of solitude. We believed the sun's gravity was an absolute border, a wall that kept our family of planets safe from the chaos of the galaxy. But in 2017, that illusion was shattered. The arrival of Oumuamua, the first confirmed interstellar object, proved that our system is not an island. It is a crossroads. By definition, an interstellar object is a wanderer that originates from outside our solar neighborhood, untethered to any star. While we have only detected a handful, statistical models suggest a far more unsettling reality at any given moment. There are likely thousands of these cosmic ghosts drifting silently through the dark between the planets, too faint for our telescopes to see. We live in a dark forest, teeming with invisible travelers. Most are harmless shards of ice passing in the night. But the laws of probability dictate that eventually the dark will send us something that does not just pass by. It will send a monster. And if Oumuamua was the whisper, then 3 Atlas is the answer, louder, heavier, and far less forgiving. If Oumuamua was a warning, the newly discovered object 3 Atlas is the threat. Discovered in 2025, its classification code tells a chilling story. The number 3 marks it as only the third visitor we have ever spotted, and the I stands for its interstellar origin. But the similarities end there. Where Oumuamua was a slender, splinter-like object, perhaps 400 meters long, Atlas is a leviathan. Early radar cross-sections suggest it is massive, potentially 14 times larger than its predecessor. In the cold calculus of impact physics, this size difference is catastrophic. A larger mass does not just mean a bigger crater. It means exponentially more energy, more heat, and more vaporization. While Oumuamua was likened to a scout slipping quietly through enemy lines, 3I Atlas approaches with the weight and presence of a cosmic dreadnought. To understand the scale of the danger casting a shadow over Earth, we must first look back at the visitor that started it all and the strange anomalies it left behind. Because understanding the first visitor isn't nostalgia, it is preparation. Knowledge is the only shield we have before velocity becomes fire. To understand the monster currently bearing down on Earth, we must re-examine the file of the first visitor that broke our reality, Oumuamua. When it flashed past our sensors in October 2017, astronomers scrambled to classify it. Roughly translated from Hawaiian, its name means a messenger from afar arriving first. A poetic title for an object that defied every convention of planetary science. In our solar system, comets and asteroids are familiar creatures. They are the crumbs left over from our sun's formation, typically shaped like uneven potatoes or spheres drifting at predictable speeds. Oumuamua was different. It was a cosmic splinter, an elongated cylinder, estimated to be 10 times longer than it was wide, a cigar or cucumber shape that has no precedent in our local neighborhood. But it wasn't just the shape that was unsettling. It was the movement. Local asteroids rotate with a rhythmic, predictable spin. Oumuamua, however, was tumbling end over end, spiraling through the void like a ship that had lost its engines or a piece of debris ejected from a violent cataclysm. This chaotic rotation suggested a turbulent history, a violent ejection from a dying star system long before humans walked the Earth. It was a tumbling messenger, silent and dark, absorbing 96% of the light that hit it, making it harder to track than a stealth fighter. Yet, as strange as its geometry was, the true anomaly lay in its physics. The defining moment of the Oumuamua mystery was not its arrival, but its departure. As it swung around the sun and headed back into the deep dark, it did something impossible. It accelerated. Gravity dictates that a rock slinging past a star should slow down as it climbs out of the gravity well. Oumuamua sped up. It was moving at 87 kilometers per second, far too fast to be captured by the sun, confirming its interstellar nature, but it possessed an unexplained non-gravitational acceleration. In normal comets, this is caused by outgassing. Ice sublimes into gas, creating a jet that pushes the rock like a thruster. But Oumuamua had no tail, no visible coma, no gas cloud. It was a silent engine. This discrepancy tore the scientific community apart. On one side, astrophysicists like Avi Loeb dared to suggest the alien probe hypothesis. Perhaps the object was a light sail, an artificial membrane pushed by the pressure of solar radiation, or a defunct piece of alien technology drifting through the stars. On the other side, naturalists proposed exotic solutions, theorizing it was a hydrogen iceberg, a fragment of pure frozen hydrogen that would outgas invisibly, leaving no trace. While the debate over Oumuamua remains unresolved, it taught us a crucial lesson. The galaxy is populated by objects that do not play by our rules, but where Oumuamua was a fast, elusive riddle 3. Atlas is a brute fact. It does not hide its nature. It displays a coma and a tail behaving like a classic comet. But its true terror lies not in what it is doing, but in how long it has been doing it. 3i Atlas is not from our neighborhood in time or space. By tracing its hyperbolic trajectory backward, astronomers have pinpointed its origin, not to the calm, flat plain of the Milky Way where our sun resides, but to the thick disk. Our galaxy is structured like a layer cake. The thin disk is the modern layer filled with gas dust, and young bright stars like our sun categorized as population Y. Above and below this lies the thick disk, a ghostly halo of ancient stars classified as population 2 moving in chaotic plunging orbits. This is the nursing home of the galaxy populated by stars formed in the Milky Way's turbulent infancy. Data suggests 3i Atlas was ejected from this violent region approximately 7 billion years ago. To put that in perspective, when this object began its journey, the Earth did not exist. The sun was not even a nebula. For eons, this lonely traveler has drifted through the void, witnessing the birth and death of star clusters, surviving the radiation of open space, and navigating the gravitational tides of the spiral arms. It is a time capsule from an era before life, a relic of the deep time that makes human history feel like a single tick of a clock. It is an elder of the cosmos, and it carries the chemical scars of its birth. The most disturbing aspect of 3i Atlas is its composition. Spectroscopic analysis of the gas sublimating from its surface reveals a shocking abundance of heavy metals, specifically iron and nickel, alongside the usual water and carbon dioxide ices. In the early universe, the thick disk was a chaotic forge. An era of intense star formation known as a starburst led to massive supernovae explosions that seeded the region with heavy elements synthesized in the cores of dying giants, the alpha process elements. Rewire. Atlas is a fragment of that primordial shrapnel. It is likely a flying mine, a dense metal-rich body concealed beneath a crust of dark organic gunk known as tholins, formed by billions of years of cosmic ray bombardment. This metallic nature changes the equation of our survival. A ball of fluffy ice might break apart in our upper atmosphere, creating a spectacular but survivable airburst. But a solid iron-heavy nucleus acts like an armor-piercing round. It has the density to punch through the atmosphere and reach the surface intact. We are not facing a snowball. We are facing a prehistoric cannonball forged in the fires of a young galaxy and hardened by 7 billion years of cold. And now, physics is about to turn that mass into energy. What comes next is no longer history. It is the math of impact, where numbers replace mercy. Human intuition is calibrated for survival on the African savanna, not for orbital mechanics. When we imagine a threat, our brains prioritize size. We fear the mountain falling from the sky. We assume that the Chicxulub asteroid, the 10-kilometer-wide Leviathan that ended the Cretaceous period, represents the ultimate ceiling of destruction. compared to that giant three-eye atlas with a diameter of roughly 5.6 kilometers, seems almost manageable. It is half the size. Intuition tells us the damage should be half as bad. Intuition is wrong. In the cold court of astrophysics, size is only a secondary witness. The real judge, jury, and executioner is velocity. The universal law behind this destruction is the formula for kinetic energy E sub k equals 1/2 mv squared. Mass represented by m increases the energy only in a linear way, but velocity represented by vvv is squared. This exponent is the most lethal factor in physics. Doubling an object's speed does not double its energy, it multiplies it by 4. Chicxulub was a lumbering giant striking Earth at a relative velocity of about 20 kilometers per second. ʻOumuamua Atlas is a kinetic sniper round. Because it falls from the depths of interstellar space unhindered by the sun's orbital friction, it arrives at our doorstep traveling at a minimum of 61 kilometers per second. At this hypervelocity, the math turns monstrous. Despite being significantly smaller and lighter than the dinosaur killer, Atlas carries roughly 4.5 times the kinetic energy. It is not a rock, it is a mathematical trap. We are not threatened by the mass of the object, but by the sheer unbridled ferocity of its motion. At 61 kilometers per second, the rules of material science disintegrate. We are used to objects colliding like billiard balls, rigid bodies hitting rigid bodies. But 3i Atlas moves so fast that the chemical bonds holding it together are rendered irrelevant by inertial forces. Upon contact with any resistance, whether it be rock or thick atmosphere, the comet will not behave like a solid. It will behave like a hydrodynamic fluid. This is the regime of hypervelocity impact physics. If Atlas were to strike, it would not crash in the traditional sense. It would cease to exist as a physical object, instantly undergoing a phase transition from solid ice and iron directly into a superheated gas and plasma. The projectile and the target rocks would mutually penetrate, behaving like splashing water, but water made of vaporized stone. This phenomenon results in instant vaporization. There is no crunch, no crumbling of rocks. The kinetic energy is dumped into the target so rapidly that the rock does not have time to move out of the way. It simply explodes at the atomic level. A 5.6 kilometer object moving at this speed contains enough energy to punch a hole through the Earth's crust and deeper into the mantle, creating a transient crater that opens and closes like a fluid wound in the planet's skin. But before it even touches the ground, it must face the first line of defense, the atmosphere. And at Mach 180, the air itself becomes a wall. And once the trap is sprung, there is no pause, only the countdown. Let us run the simulation. The simulation clock sits at T-1 second. You are standing on a beach looking up. The sky is blue, the air is still. You are about to witness the end of the world, but you will not hear it. 3. Atlas hits the upper atmosphere. The Kármán line, 100 kilometers above your head. At 61 kilometers per second, the air molecules in front of the comet cannot move out of the way fast enough. They are trapped against the nose of the object, compressed violently in a process called adiabatic compression. This is not friction. The air isn't rubbing against the rock. The air is being crushed so hard and so fast that its temperature spikes to over 20,000 degrees Celsius, hotter than the surface of the sun in a fraction of a millisecond. From the ground, you see a spear of blinding violet-white light stab downward from the heavens. It connects the top of the sky to the horizon in a single heartbeat. The human eye cannot track it. The brain registers it as a solid beam of light appearing instantaneously. Inside this plasma sheath, the comet is already dying, ablating and screaming as it forces a vacuum tunnel through the atmosphere. The radiant heat from this plasma lance is so intense that it blisters skin and ignites forests within the line of sight before the object even touches the ground. The shadow of death arrives at the speed of light. The sound of death is still lagging minutes behind. The comet strikes the ocean or the crust. It takes less than 1 second for the entire 5.6 kilometer body to bury itself beneath the surface. In that instant, the kinetic energy is converted into thermal energy and shock pressure. The comet vaporizes. The crust vaporizes. A hemispherical shockwave expands outward through the bedrock, turning solid granite into a fluid that ripples like a pond. We call this peeling the Earth. The explosion excavates a crater dozens of kilometers deep and over 100 kilometers wide within seconds. Trillions of tons of molten rock, superheated steam, and vaporized metal from the comet's core are launched upward. This ejecta curtain rises into the stratosphere, some of it moving so fast it achieves suborbital trajectories, raining back down on the other side of the planet like ballistic missiles. The shockwave in the atmosphere hits next. Winds of 1,000 kilometers per hour, stronger than any hurricane in history, scour the surrounding continents, flattening cities, stripping forests to the bedrock, and pulverizing everything standing. If the impact occurs in the ocean, the energy transfer creates a mega-tsunami. Unlike surface waves driven by wind, this is a displacement of the entire water column. A wall of water, potentially kilometers high at the source, races toward the coastlines, penetrating hundreds of kilometers inland, erasing the distinction between land and sea. The fire and the water are the immediate executioners, but the chemistry is the torturer. The impact of 3 Atlas does not just break rocks, it breaks molecules. The passage of the comet and the explosion that follows generate a shockwave powerful enough to tear apart the strong triple bonds of nitrogen molecules in our atmosphere, written chemically as N2. The freed nitrogen reacts instantly with oxygen and forms nitric oxide, written as NO. As the mushroom cloud rises into the stratosphere, the gas cools and transforms again into nitrogen dioxide, NO2, a toxic brown vapor. When this nitrogen mixture meets the trillions of tons of water vapor forced into the atmosphere by the impact, it reaches its final and most lethal form, HNO3. It becomes nitric acid. In the weeks following the impact, it begins to rain. But this is not water. It is a corrosive downpour with the pH of battery acid. This atmospheric alchemy scours the land. It dissolves the leaves of the few surviving trees. It falls into the oceans, acidifying the upper layers so rapidly that the calcium carbonate shells of plankton and coral dissolve. The base of the marine food web collapses. The oceans, already choked with silt, become toxic pools. The poisoned sky ensures that even those who survived the blast in deep bunkers will emerge to a world that burns to the touch. Finally, the silence falls. The dust, ash, and soot from burning continents circle the globe, choking out the sun. This is the impact winter. For years, possibly a decade, Earth is plunged into a twilight darkness. Photosynthesis stops completely. The food chain, broken at the bottom, crumbles upward. Herbivores starve. Carnivores turn on each other, then starve. Civilization dependent on agriculture vanishes. But 3 Atlas has one final twist, a parting gift from its origin in the thick disk. The comet was composed largely of carbon dioxide ice. Upon impact, this massive store of dry ice sublimated instantly into gas. Furthermore, the vaporization of Earth's carbonate rocks releases vast amounts of ancient trapped carbon. As the dust slowly settles and the sun returns years later, the planet does not return to normal. The high concentration of atmospheric carbon dioxide, CO2, traps the returning solar heat. The Earth swings violently from a deep freeze into a runaway greenhouse event. The planet bakes. The few species that adapted to the cold of the winter are now roasted by the heat of the recovery. This climatic whiplash, freeze then burn, is the ultimate great filter. It is the mechanism by which the universe resets the clock of biological complexity, leaving only the smallest, toughest microbes to inherit the ruins of the world. But this ending lives only in simulation, a shadow of what could have been if fate had leaned 1 degree closer. Fortunately, this simulation remains just that, a ghost story told in the language of mathematics. The reality is far less violent, though no less humbling. According to the latest trajectory models calculated by NASA and ESA, 3I Atlas will not intersect Earth's orbit. At its closest approach in December 2025, the comet will pass at a safe distance of 1.8 astronomical units, which is roughly 270 million kilometers from our planet. To a human, this distance seems immense, a vast gulf of safety. But to a galaxy, it is a razor's edge. Atlas will pierce the plane of our solar system, diving within the orbit of Mars, missing the red planet. by a mere 28 million kilometers before slinging around the sun and vanishing back into the deep dark. We have won the cosmic lottery in the grand game of celestial billiards, where gravitational fields act as the cushions and kinetic energy drives the cue ball. This shot was a miss, but it was a near miss. The difference between a curious scientific anomaly and an extinction-level event was simply a fraction of a degree in an orbit determined 7 billion years ago. If 3I Atlas had been nudged slightly by a passing star eons ago, or if it had arrived a few months later when Earth was in a different position, the simulation described above would not be a hypothesis, it would be our forecast. The arrival of 3I Atlas is not a harbinger of doom, but a stroke of extraordinary luck. It serves as a wake-up call, shattering the complacency that our corner of the galaxy is quiet and tamed. The solar system is not a sealed room, it is a busy intersection, and we are merely pedestrians who have until now avoided the traffic. But more importantly, 3 Atlas is an opportunity. This object is a pristine sample from the thick disk, a frozen library containing the chemical history of the Milky Way before the sun was born. It holds secrets about the starburst era, the formation of the first heavy metals, and the chaotic environment that eventually allowed systems like ours to form. By studying its spectra as it outgasses near the sun, we are not looking at a rock. We are looking into a mirror of deep time, seeing the violent ancestry that created the iron in our blood and the carbon in our cells. The executioner has passed us by, leaving us with a gift, but its passage leaves a lingering question in the silence of space. How many others are out there? How many ancient invisible dreadnoughts are drifting in the dark, their trajectories locked on a collision course with a date yet to come? For now the sky is clear, the simulation is over, but the watch must continue.